Let's do more examples on first principle. We have f of x is equals to x squared plus 1. What you're going to do here, you will have to find f of x plus h. And in this case, obviously, where there's x, you will simply substitute x plus h. This is the formula that we're going to be using here. We need f of x plus h, and we also need f of x. We do have f of x. The only thing that is missing is f of x plus h. Hence, where there's x, I substituted x plus h and I squared it. Then I added 1. So basically, all I did was just to go into the original function, and where there's x, I just substituted x plus h. Meaning that in the formula where there's f of x plus h, I'm going to substitute this x plus h squared plus 1. And in the formula where there's f of x, I am going to substitute x squared plus 1. Hence, I've got that. Get rid of brackets. I showed you in the previous video how to get rid of brackets that are squared. You just have to use that short formula. But please note that this bracket here, for me to get rid of this, I only have to multiply out by -1. Hence, I've got that. Okay. Now, you realize that this cancels with that, and that cancels with that. Actually, 1 minus 1 is 0, x squared minus x squared is 0, so I'll be left with 2xh. Now, all I have to do here, for me to get rid of that h in the denominator, I just had to take out h as a common factor in the numerator. That will cancel with that. I'll be left with limit of x plus h, and now we'll substitute 0 where there's h, and f prime x will be equal to 2x. That is all you were supposed to have done here. Let's check the next example. The next example is 2x plus 1. This is pretty much quite easy. You just have to use the formula find f of x, which is 2x plus 1. Find f of x plus h. You just go to the original equation where there's x, you substitute x plus h, and this is what you're going to get. Now, this will be substituted there, and this will be substituted there. All right, that is because it is equals to f of x, and hence we have this. Okay, I'm going to put it in brackets because I'm subtracting. Now, to break the brackets, I'm just going to multiply by -1. And this is what I'm going to have here. 2x minus 2x is 0. 1 minus 1 is 0. I'll be left with 2h over h. And then I'll be left with the limit of 2. When I substitute 0 there, I'll just get, I will just get 2. Okay, so in this case, it means that the derivative of the tangent to this line will always be equal to 2. What about this one here? You do exactly the same thing. Where there's x, you're going to substitute x first. You're going to find f of x. F of x is simply 1 over x. And f of x plus h, where there's x in the original equation, you will just substitute x plus h. There it is. So basically, where there's f of x plus h, I'm going to substitute that. And where there's f of x, I'm going to substitute that. Now, in the numerator, you just have to find your LCD, and once you have found your LCD, obviously you will need to simplify the fraction in the numerator. And the fraction in the numerator, when you simplify it, it will be this, all right? You'll realize that that 1 must be multiplied by x, and this -1 here must be multiplied by x plus h. That is why I've put that x plus h in brackets. And in the next, obviously, this is still divided. This division sign of this division line, I've just changed it to a division sign. So I haven't actually done anything. It is still this h, but that h will be divided by 1. Now, for me to simplify further, obviously I'm going to break this bracket here. Once I've broken that bracket, I will change this division sign to multiplication. When I do that, h goes to the denominator, 1 goes to the numerator. And this is what I'll be left with. I'll be left with minus h in the numerator. However, that minus h will cancel. Note that this h here, I multiplied it with the denominator, with the whole of denominator, and there it is. So I have hx into x plus h. That cancels with that. In the numerator, I'll be left with negative 1 over x into x plus h. Now I can start substituting 0 where there's h, and I will simply get that. So basically, this is the equation of finding the gradient of the tangent to the line at any specific point. Now let's check this one here. You'll still do the same thing. You use this formula. We do have f of x. All you have to do is to find f of x plus h. Now this is what you're going to have. Please note that this bracket here, for you to be able to simplify this, you have to repeat that bracket twice. Okay. Now when you repeat it twice, basically what I did here is simply to write it as x plus h, and I still have x plus h squared. Now simplify the squared one first. Obviously this one is quite easy, because when you simplify this, you're going to square x, and then you multiply everything. X times h times 2 will give you 2x. That is the middle term, and the last term, you just square the last term in the bracket, which is h. When you square h, it'll give you h squared. I still have that as it is. I haven't changed anything, which is my f of x. F of x is equals to, please note that f of x was equals to 2x cubed minus 3. So because I have minus here, when I substitute that 2 plus 3, I had it in bracket and it was negative. So when I multiply out by negative, this negative changed and became positive. Hence we have it over here as positive as well. Now for this one here, I'm going to break this bracket just like I broke that one to get this. Now I'm going to break this bracket exactly the same way. You can only multiply, actually simplify this bracket first, and then you're going to have a binomial with a trinomial, and then that's when you can start multiplying out the binomial with the trinomial. Okay, you can't multiply everything at once. I've just showed you everything, all the workings step by step here. All I did was I broke that bracket as I've said, and this is what I've got, and then I multiplied out, which is a binomial multiplied by a trinomial, and this is all I have. So basically, for me to get all of this, this is what I did. And it gave me all of this. Please note that this 2 is still outside. I have not touched it at all. Okay, now here all I did was this. I multiplied this trinomial by that negative 3, and I got this. And I still have this minus 2x cubed plus 3x squared minus 2x cubed plus 3x squared. Okay, and this is what I got inside the brackets. Obviously outside here, I'm gonna have that minus that. Okay, now once I've simplified everything in brackets, please note that this is the same as that. It'll give you this, and this is the same as this, and it'll give you that. Okay, so basically all I did was 2x squared h plus x squared h. It gave me 3x squared h, and x h squared plus 2x h squared will give me 3x h squared, and I still have that h cubed. Now all I have to do to break this bracket is multiply this bracket out by that 2 that is outside. Obviously, when you multiply this by 2x cubed, multiplied by 2 will give you 2x cubed, and 3x squared h multiplied by 2 will give you 6x squared h, and 3xh squared multiplied by 2 will give you 6xh squared, and I'll have 2 times h cubed will give me 2h cubed. I still have that minus 6xh, and I still have this minus 3h squared minus 2. Please note that they come from there, and they came from that as well. And for me to get to this, I simply multiplied out by negative 3. Okay, now that will actually minus with that, and they will give you 0, and I'll be left with this whole equation here, of which I can't do anything with. All I have to do is to take out h as a common factor, and h will cancel out, and I'll still be left with this whole thing that is inside the brackets, which is that over there. Once I've gotten rid of that h, I can now substitute 0 where there's h, which is what I did. And it will give me 6x squared minus 6. This is the activity that you need to do.